So, what do you know about percentages of increase or decrease? Have you heard that before? Sometimes it is called percent of change, like it will be called on the worksheet. What do you know about that? What do you think it might mean?
What do we think percent change means?
Yeah, or increase, decrease. What does the word increase mean?
Uh,
Go up. What's decrease mean?
Now,
Those are both changes, right? So percent of change kind of says the same thing in both terms. Okay, there are many, many things in this world that we put numbers on. Much data is quantitative. We can assign a number to it. Think of any sort of situation where a number is applied to that situation. Where's a place in the world that you use numbers?
math class.
Math, more specific. All right, outside of the math class. What's the last time that you saw a number, that you knew a number?
My
In,
address.
in the store, your address. Okay, that is represented by numbers, and that's probably a good example that won't really fit unless you moved up the street and your address moved up a couple of numbers.
Your phone
Okay.
percentage.
Your phone percent. Oh, okay. So last time you looked at your phone, what percent was your battery at?
98.
98. And so as it sits untouched in your backpack until that final bell of the school rings today, what do you think it will be on by then?
Probably like 97. Probably 95.
Maybe 95. Okay. So he had an original amount this morning, which was, did you say 98? And by this afternoon, he figures it's going to go down to 95. Not much change, but there was a change, right? Was it an increase or a decrease? Okay, we could find the percent of change, not just the fact that those are 2% and we could subtract them, but we can find the percent of change. Give me something else that you have had a number on lately. You've seen an amount. Money. Okay. Let's money in your wallet, money spent at the store, money in your bank account, money in your wallet. Okay. Um, give me a thumbs up for an increase, thumbs down for the decrease. In the last week, has the amount of money in your wallet changed?
Yes.
Increase? Decrease? Mine's going up and down because it was going down, so I put some more money in my wallet and it went up, and then I spent the money and it's going back down again. So there's been a lot of ups and downs with the amount of money in my wallet. As a matter of fact, in my actual wallet, I don't know what's in there, but it's not what it was a couple weeks ago for sure. Okay? So we can find the percent of change there. Okay? So let's find out how to do it. Okay? Anybody else have a different example? You good? Okay, well, let's see what's going on here. Okay, we've got a couple of terms we need to be familiar with. One is absolute change. Now, where have we word be used? That is not even a proper sentence. Where have we used the word absolute in this math class before? Absolute value. Tell me what you know about absolute value. Thank you, Captain Obvious. The value is absolute. That's not what I was looking for. So we need a little more insight into what absolute value means. To me, two things come to my mind. One is the official definition, and the other is kind of what does absolute value do to a number. So, does absolute value make a number the opposite? I've got a strong head shake. Okay, well he redeems himself with the definition of absolute value. The absolute value of a number is the distance it is away from zero. So if I was looking at a number line, how many spaces from zero is the number 10? 10. So the number was 10. Its distance is also 10. So is the absolute value the opposite of the original number?
No.
Oh, but what if I said I was looking at a number line and I was looking at -7? What's its distance from zero?
7.
So its absolute value is 7. So in that case, it is the opposite. So it only really changes a negative number, doesn't it? But in both cases, we're talking about the distance from zero. So what could we say about absolute value? What does it always do to a number? It doesn't always make it opposite.
0 is the starting point.
Okay, 0. It always makes the number positive because distances don't usually get a positive or negative with it. So if we don't put a negative, it appears to be positive, right? So absolute value is a tool in mathematics to make sure things stay positive. And you know where it gets used in math a lot? With the number line, but it gets used a lot with subtraction. Because what happens if you subtract two numbers to find the difference between them, but you happen to put the smaller number in your calculator before the bigger number? What's going to happen? Bust out your calculator. Alexis, pick a number, any whole number. 2. Thank you. Jerry, pick a whole number that is larger than 2. 5. If I subtract 2 minus 5, it's going to give me a -3, right? I thought it said 2. I was like double checking my calculator. Okay? So, but what if I'm in a situation where I don't want it to have a sign? I just want to know how far apart the numbers are from each other. And I could say, give me the absolute value of the difference. What does the word difference mean in math? Subtraction. So there are times when you will be subtracting and we do not care whether you get a positive or negative. I just want to know the difference in the two numbers. Carson, how old are you?
16 years of age.
16 years of age. Well, guess what? I'm not. So there's a difference between our ages. Okay? So how can we find the difference between his age and mine? We need to know my age. I told you how old am I? Do you know how old I am?
No.
62. So if I wanted to know the difference between our ages, I heard Carson's age first, right? And then I heard my age second. What's going to happen if I subtract that?
Maybe like 40 something.
40 something. Is there a negative 46 years between us?
No.
No, there's just 46 years between us. So I might ask you to get the absolute value of that. Now, the easiest way to get the absolute value is subtract whichever way you want and ignore the negative if you get a negative. Because if I had put my age in first and then his age, it would have been positive. That's pretty much the easiest way. But did you know that the calculator can give you an absolute value? Okay. It is in your calculator. I haven't done it for a while. I think it's under the math section. And do you see absolute value somewhere there? I don't. I think if I go over. Oh, there. Okay. Let me show you what I just did, okay? I went to math, found the math button, and it's something I'm going to do with numbers. So I'm going to use the side arrow and go to the right one, and it's the very first thing right there. And if I hit enter, then it says, put your little subtraction expression in here, and I'm going to make it positive for you. So let's do it the first way. If we do the 16 minus the 62, we get the 46. Now, do you think it's worth the time to hit math, move over, hit enter, to put your equation, your expression there, or could you just ignore the negative if you don't want? Okay, so there you go. But the absolute change is the absolute value, meaning we want the positive version, of the difference. So it doesn't matter which order you put the numbers into the calculator, you're just going to ignore the negative, right? The distance between the original and the new amount. Y'all, I was 16 once. That was back in, when did I turn 16?
What was your first car?
I think I turned 16 in 1979. My first car, I didn't get my first car until I was 19.
Jeez.
Maybe 18 or 19. It was my junior year in college. So I was either 18 or 19. I know I graduated when I was 20. By then, we were on the second car. So I had that other car. Maybe I was 19, 18.
Do you remember what it was?
Well, my first car, it was a Vet. A Chevette. Not the same as a Corvette. It was a lovely little vehicle. Let me show you what we're talking about here. It looked just like this guy. Hold on. Open it up. I'll just drag that over. I'll just drag this over. Oh, looks like that guy. My dad gave it because my first loan engine rebuilt. So then I had to have a job to pay back the loan to rebuild the engine, but it still kept leaking oil. So then I had to have a second job to get enough oil to put in the car to go to the first job to pay for the loan to fix the car that didn't really fix. So anyway, so I drove that thing for over a year, and then the engine threw a rod, probably because it hadn't put enough oil in it, and then we bought a Volkswagen. Then I was about to get married. Yes, Super Beagle, a 1972 Super Beagle. Yeah, also red. Anyhow, so now let's move on. Okay, absolute change is the new amount minus the original amount. Okay, so, and I've got a little AKA here. So, also known as what? Okay, so what's subtraction known as? What difference? That's what I'm after. Okay, because this right here, difference. This is the way the book suggests you find percent of change, and you may love this formula. You can get the absolute change. How do you get absolute change between a new amount and an old amount? You subtract. You can put that over the original amount, and you can multiply by 100. Okay? Or they say you could take the difference. If you look at that, absolute change is the difference, right? Over the original times 100. If you really liked the percent formula the other day, where we wrote a proportion and there was a 100 right here, didn't any of you really just kind of like to set things up that way? Then here's the way you can get percent of change using a proportion, and that's what I usually think of. So on top, I'm going to put DIFF, which means what? Difference
And I'm going to draw some absolute value bars around it, just so what? Okay, make it positive. So you always want to put a positive number here because you don't want to give me a negative percent of change. We will indicate that with a word, not with a sign. Okay? The difference between the old and the new, okay? Or maybe I should say the original amount and the new amount. All right? Because the formula says original. Are you okay if I just put O-R-I-G and you'll know I'm talking about really original? And what always goes over 100 in our formula? A percent. So if I am looking for the percent of change, then this formula will work. So this may be the one you like best because the entire 4.4b worksheet is doing this. Okay? But we're going to play with it in some situations given to us by the book. So part A, B, and C all go with this story. An on-campus organization is trying to increase its monthly attendance. Maybe it's the student council for the university. Maybe it's, I don't know, one of the clubs, okay? Maybe it's one of the sororities or fraternities. They're trying to increase their monthly attendance, huh?
Uzma Kappa.
Uzma Kappa? Okay, what?
That's a majority.
Okay. What?
That's a thing.
Okay, slow it down and say it again.
Uzma Kappa.
Uzma Kappa. And is that a fraternity? A sorority? Okay. I know Kappa is one of the Greek letters, but what about the others?
It's Mike Wazowski's.
Mike Wazowski. Oh, gotcha. All right.
Austin University.
Huh? I didn't know that they had gone to the university level at this point. I haven't kept up. All right, moving along. After a big recruiting push, the meeting attendance increased from 25 to 38 people. What's the percentage change in attendance? And this is the version I'm going to use in every example. So first of all, if I want to put the difference over the original, how do I get the difference between the two attendance amounts?
38.
Okay, I could just do 38 minus 25. If I just choose to put the big number first, it's always going to be positive, right? So what is the difference? How many people did it change by? By how many? By how many?
13.
Oh, I thought you were saying 32, and I was like, where are you getting 32? Okay, 13, yes. Now, which number was the original?
25.
Because it happened first, right? So we're going to put the difference over the original, and that will equal, I'm going to use an X because we don't know the percent, over 100. Does that work for you? Okay, so we're going to cross multiply. If you'd like to see the scratch work, 25 will multiply times the X. 13 will multiply times the 100, giving me 1,300. Then I'm going to divide by the 25, which should go nicely, right? So what are you coming up with for your X?
I got
52.
52. What?
50%.
Now, we're not going to just say change. We're going to specify whether it was an increase or a decrease. Because on your worksheet, I'm looking for that as well. So if you just give me this, you will not get all the points. So, did it increase or did it decrease? Okay, increase. I am not giving you permission to abbreviate that. Spell the word increase. What?
Would like an addition or subtraction sign also show you the increase or decrease?
So, since percent of change can, a negative percent of change pretty much indicates that it went down, but usually they don't associate positives and negatives with it. It's just, this is the percent of the change, and if you wanna specify what happened, we typically just say, and it went up. We usually use words with that. So I've never really worked in any book that they would expect you to come up with a negative, especially if we're going with the formula that has an absolute value. You really wouldn't come up with a negative number. So we're going to follow the way it's usually done in math, and I'm going to say, now you tell me, was it an increase or was it a decrease? Okay? Still following this same little story, during the third meeting, so they have a third meeting, right? Only 31 people attended. What is the percent change from the second meeting to the third? So we got to make sure we've got our correct information. How many people attended the second meeting? 38. This was your first meeting. That was your second meeting. This is your third meeting, right? So we're going with the 38 from part A. And what was our third meeting?
31.
So what word is going to be in my answer? Decrease. But how are we going to find it? Okay, so 38 minus 31 is?
7.
Now, if you had punched into your calculator 31 minus 38 and it gave you a negative 7, what would you have written down right here? 7. And what's the original? And it's not the original from part A. Which one of these was the original?
38.
Okay, because this is only asking about the change between the second and the third meeting. So at the second meeting, we had 38, and that changed by 7 people. X over 100. So we're only talking about the second to the third here. All right, so 38 times X equals 700. I don't think this is going to divide all pretty like. Does it vomit decimals all over the place? All right, so let's look. Where did they tell me to round?
Nowhere.
Oh, then whatever will we do? Stewart standard.
18.4.
Okay, I've got 18.4 what?
2.
Does anybody else back up the 18.42? So 18.4, I'm going to put X equals so it looks like I finished up my algebra. 2, what else does this need? What else does it need? It needs a percent decrease. Okay, Stewart standard. Now, when you get your assignment, you need to read to see if they tell you where to round. This one didn't tell me, so I resorted to the Stewart standard. All right, part C. For advertising purposes, the organization decides to promote the overall increase in attendance for the 2-month span. So we want to calculate the percentage change from meeting number 1 to meeting number 3. So what was the attendance at meeting number 1? 25. What was the attendance at meeting number 3? 31. Which one of those is my original? How did you know that? It's what happened first, the original. Okay, and our formula is difference over original equals percent over 100, no matter what the book says. I just like this because it's in the format of other percent formulas that we've used this week. What other percent formulas have we used this week that had this percent over 100? No, that doesn't answer the question. You keep giving me non-answers. Think, what's one of the... So we had something over something equals percent over 100. We have 2 of them. You have resources. Flip pages, people. Huh? We have part over whole equals percent over 100. What did you use 2 worksheets ago? Is over of. Okay, and so now we can say difference over original if it wants the of change. So, what's the difference that you're getting between the 25 and 31? You might even do that in your head. What's the original? Equals x over 100. 25x equals 600. That should divide very nicely. 24% increase. Everyone, oh no, nope. I was about to say every one of these examples was an increase, but that would be a total lie, right? Because after their big push and they got their attendance up at the second meeting, then the third one, people were like, that was not an exciting meeting, they didn't come. Okay? Overall, 24% increase. This is the worksheet I'm about to put into your grubby little paws. Okay? It's got what? It's got no back to it. It's got a whopping 12 problems. Now, there's a good chance that you might finish this period. So, what should you do with your time after that?
So extra credit.
Okay, extra credit for the Delta Math. Okay, and then practice problems. Tomorrow, I will be giving you the Unit 4 major grade, which is called applications. It is using all the things that we learned in this unit. So practicing the odd problems throughout this unit is going to help prepare you. Here's what you will have as tools while you do the major grade. You can use the book. That would be that helpful. You can use your notes. I think that should be very helpful. You can use a calculator. I think that will be incredibly helpful. You cannot use a buddy. So, you're going to have to know what you're doing. And it's got a little bit of everything. So, anyway, percent of change. Let's see what the directions tell us that might be important. Find each percent change. Okay, let me put this in front of y'all. Let's put a couple of things up here that we need to know. First of all, let's put a due date on this guy.
Friday.
How many of you think it's going to be turned in today?
All of us.
All of you, okay? So, this is due Friday, what's the date for Friday? 10/24, okay? You are finding the percent of change. Would it maybe be helpful for you to have the formula at the top of the page that we've been using?
Perchance.
Okay, per chance. What's that formula look like?
Original, or difference over original.
Difference
Equals X
over original equals, we're going to say percent over 100. On this page, they're looking for the percent every time. But could you use this formula if I told you the percent of change and I told you the original? Could you use it to find the difference? If I told you the difference and the percent, could you find the original? Okay, so if I said something like, my water bill increased by $6 this month, which was a 5% change. You could find the original. Okay. Oh wait, yeah, no, I need to tell you something else. I would have to give you one more number. I'd say did I give you 107? Did I say it went up to 107? Okay. My water bill went up to $107 this month. I said, which was a 5% change. You could find the original one. Okay. So anyway, what else is important to know on this page? Okay, you must state if it is an increase or a decrease. So if you do not write that part, you're going to lose some points. They're about 8 points each. I don't remember. I have to look and see my answer from last year, how much I took off. I don't know if I took off half or less than half for that.
Yeah, just make it the whole problem wrong.
Whole problem's wrong. Absolutely. No, I'll consider it briefly and probably go with me. Okay, what else is important to know?
Round to the right decimal place.
Yeah, what is the correct decimal place? How do you know what the 10th looks like?
Oh, you do.
I do, Mr.
Yes.
Non-answer. How many places are we rounding to, people?
4.
1 decimal place. What else are you gonna have on your answers?
Percentile.
A percent sign. You got it? All right. So enjoy the math.
That's it.
Then I'll